I have another puzzle for you that relates hash codes and equals. So let's suppose we're in the same setup we described a little bit earlier, where we have a colored number class which overrides equals, and it compares the two nums, right? So any 16 is equal to any other 16. And let's suppose we also do not override hash codes. So we end up getting this distribution of items. For example, 3, 8, and 9, by pure chance, land in bucket 2. So let's suppose we now create a new colored number, 0, and we add it to the hash set. My question for you is, do we get another 0 in our set? Okay. So there's 4 things we can imagine happening. One is this top bucket that, again, sorry, my face is blocking, but one possibility is we end up with a 0 getting added to bin 0. Another possibility is that we add another 0 to bin 1. So we end up with 2 zeros in this bin. And by the way, people use both the words bin and bucket. It's so seamless to me that I didn't actually say bin before, but a bin and a bucket are the same thing. A third possibility is we add a 0 to some other bin. So for example, a 0 ends up at the end of bin 2 or 3 or 4 or 5. Or a fourth possibility, there is no 0. It gets blocked. Okay. So I'd like you to think about which of those 4 things can happen, and it turns out more than one can. And just like before, there's going to be some non-determinism depending on where the address of colored number 0 ends up being, this new one we create here. Okay. So it turns out the possibilities are A, C, and D. So A would be the case if we try to add this 0 and its hash code its hash code, which is its memory location, mod 6, happens to be 0, it'll end up getting added to bin 0. Or imagine that the new colored number we create, it happens to have hash code 5, hash code mod 6 happens to be 5. Then what would happen is the hash set would look and it'd say, are you 0? No. Are you 0? No. Are you 0? No. Are you 0? No. There's nothing left, so I'm going to put it in the back of the bucket. Okay, so that could happen. And it can also be the case we don't even get a duplicate 0. So for example, imagine that the hash code of the new 0 we create happens to have memory location mod 6 equal to 1. Then what the hash set will do is it'll start looking here and it'll say, 0, okay, you're already here, so I don't need to do anything. It is impossible for us to end up with another 0 at the end of this bucket because the equals operation will prevent that from happening. So the second choice, we add another 0 to bin 1, that could never happen. And I guess you want to think about the chances, which I forgot I did on the slide, I will fully admit. There's a 5/6 chance that you end up in one of these other bins and you end up with a duplicate. Or there's a 1/6 chance you end up in bin 1 with no duplicate because the equals operation blocks it. So bottom line, if your class overrides equals, you also need to override hash code, and it needs to be in some consistent manner. The basic idea is that if 2 objects are equal, they always have to have the same hash code. If you don't do that, things go wrong, because then when you're trying to see, for example, is the item in the hash table, you compute the hash code, you go to the bin, but then you can't find it. So contains can't find objects unless it happens to get really lucky. With 6 bins, there's a 1/6 chance. With 1,000 bins, you got a 1 in 1,000 chance. And the other problem we saw just now is that add can result in duplicates, again, unless you happen to get lucky. But basically it boils down to is you can't find something in a hash table if equals items don't have the same hash code.